Hello, I'm Cristina and I'd like to introduce you to our Yogipaedia app, which is a product of a joint effort involving Holly, Louise and myself. With the growing popularity of yoga in the Western world and the emergence of yoga studios in cities everywhere, we've developed an app designed to provide aspiring yogis with an enjoyable method for exploring various yoga poses. Our collection of poses offers users the opportunity to find pose inspiration, either through our homepage, which features a different pose every day, or by exploring our comprehensive pose library. So let's have a look and see how our app works. Users have two options for accessing the app. They can log in using their email address and password they provided during registration, or they can sign in with their Google account. I'm just going to sign in with Google. Once successfully logged in, the user will be taken to the home page where they will see the picture and the name of a different yoga pose every day and a short history of yoga. The poses library allows the user to browse through the various yoga poses and filter through the different categories and difficulty levels. The pose library also enables users to access additional pose details and to save or remove poses from their favorites by clicking on the heart icon. To view all their saved favorites, users can easily navigate to the My Favorites page from the top navigation bar.
Hi, I'm Holly. The backend for our Yogipaedia app utilizes a REST API using Express and Node to perform CRUD operations to our relational Postgres database. We use the Docker Postgres image to have a containerized build and made use of Postman to check our API requests both during development and deployment. We used Firebase for authorization on the front end, but passed some of the Firebase data to the back end to make our account-specific API calls. We have 3 tables in our database: a users table, a poses table, and a favorites table, which stores users and their favorite poses so that we can serve a responsive My Favorites component. That table has the pose ID as a foreign key referencing the full pose table. We have separate routers and controllers for the pose and favorites API requests. The calls a user can make to the poses table are all straightforward GET requests, but with different parameters: the full list, by category, or by difficulty level. The requests to the favorites are a little more complex. The user needs to be able to create, read, and delete favorite poses. We also needed to be able to query 2 tables in our database with an inner join on the pose ID so that the API can pass the full data for each pose back to the front end in the response data, ready for rendering.
Here are the front-end technologies employed in developing our app. We constructed the app utilizing Create React App and applied Sass for styling. Figma was utilized for wireframing the app's design and user experience, while Access facilitated communication with the backend, and Firebase handled authentication. The Pose of the Day component is one of our main components. It fetches and displays a random yoga pose each day. It uses React State Management, Access for server requests, and local storage for data persistence. This component is a valuable addition to the Yogipaedia app because it provides users with daily inspiration for their yoga practice. The component starts by defining 3 state variables using the useState hook: a random image which holds the URL of the randomly selected yoga pose, pose name, and alert message which is displayed in case of a server error. The main logic of this component is within the useEffect hook, which performs the following steps. It checks if a yoga pose was generated for the current date by comparing it with the last generated date stored in local storage. If no pose was generated for today, it sends a request to the server using Axios to fetch a list of yoga poses. It then randomly selects a pose, sets the random image and pose name state variables with the selected poses data, and updates local storage with this new pose information. If a pose was generated for today, it retrieves the pose details from local storage and updates the random image and pose name state variables accordingly. And if there was an error during the access request, it sets an error message in the alert message state variable. Next, I'm going to talk about the Poses Library component, which is responsible for displaying a collection of yoga poses to users. It offers filtering options to allow users to find poses based on categories and difficulty levels. Users can also add poses to their favorites for easy access. The component uses the following state variables: poses, which is an array to store yoga poses data, selected filter, which tracks the currently selected filter, and the alert message, which is displayed in case of a server error. The component uses an Axios HTTP request to fetch yoga pose data based on the selected filter. It constructs the API endpoint dynamically. Once the data is fetched, it's transformed into a format suitable for rendering. And the component renders yoga poses as grid items. Each grid item includes a favorite button and the pose preview with image and the name of the pose. The pose library component is a crucial part of our yoga application. It allows the users to explore and learn various yoga poses, and the dynamic filtering and fetching make it a user-friendly feature.
We wanted users to have a succinct pose preview on rendering, but have an interactive way of getting a little more detail. So we used a modal component from MUI, which appends a button on the parent, in this case, pose preview. And when the user clicks on that, a modal pops up, which is escapable by clicking outside the modal. The component has on-click functions to set the open state to true or false. The elements that make up the My Poses component are modular and shared with the Poses library. We make a GET request to the Favorites table with the user ID and the request parameters. We catch the response data in our own array, which we then map over and change the state of our pose prop. The destructured objects can then be rendered dynamically. We augmented the imported Firebase code to add our own functionality to the login modal component, like setting user ID as a prop that is passed through the app using the Firebase user ID. That enables us to do the Favorites API calls tailored to each user. We used Sass for the styling so that we could make use of variables to achieve a unified appearance throughout the app and to make it easier to change fonts and color schemes if our design changed along the way.
In terms of software development practices, Figma was employed to produce two boards. One was used for compiling a Moscow task list, musts, shoulds, coulds, and woulds, and the other for creating the wireframes for the app's design. We utilized the Trello board to establish task lists that we regularly updated as our app development advanced. This approach was invaluable for monitoring the features that needed attention within each component. GitHub version control we used to store, manage, and track changes to our code repositories, facilitating team collaboration. We engaged in remote pair programming, enabling us to collaborate in real time, sharing expertise and jointly solving problems. And we chose Google Meet for conducting virtual stand-up meetings, and we used the Slack channel for communication between these meetings.
We initially used an existing REST API which had everything we needed, but had stability issues. Initially, we imported that data as a static JSON file, but in the end we inserted it into our database as its own table so that we could make more dynamic requests. Another challenge was losing a teammate partway through the development process. Cristina and I were able to refer to all of the planning and workflow resources we'd put in place and redistribute the workload pretty quickly despite the time constraints. Working out the best way to structure the favorites table and writing the query to get full pose data for just the logged in users' favorite poses took some time and a few attempts. It was made harder by a problem we had with the Firebase auth resetting to null on page refresh and on clicking the home button. At first we got around it by saving the Firebase user ID string to the window local storage, but in the end it turned out the problem was solved by setting the initial user ID state as an empty string rather than null. One of the smaller but not insignificant challenges was that we wanted this really beautiful watercolor background consistent across the whole site with some opacity to improve the contrast, but without child elements inheriting the opacity. Rather than setting it as a background image in the CSS, I added the image in its own div in the index HTML, but made it a sibling of the root and wrapped them both in a parent div. I could then add a class name to the image and manipulate it in isolation without affecting the root. I also added a Z index of -1 to make absolutely sure that there wouldn't be any conflicts further down the tree. If we had another few days, we would have loved to add another component in which users can save yoga poses into bespoke flows, and I would have liked to add a loading spinner on the poses library and my favorites page to address the occasional lag while doing API calls. We want to say thanks to our ex-teammate Louise, who did so much work on the back end before leaving. We couldn't have done it without you. Massive thank you to the incredible Command Shift tutors for your support on the final project, but also your tremendous teaching and guidance throughout the past 6 months. And also thanks to our fellow cohort members. It's been a really inspiring and collegial environment, and we wish everyone all the best after graduation. Our app is deployed on Render at the link on the screen. Do have a look, send us a message, and check out the code hosted on my GitHub account.